In episode 27 of Mobycast, we start a new micro-series discussing the setup of virtual private clouds on AWS. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
All right. Hello. Welcome, Rich and Chris. It's another Mobycast.
Hey.
Hey, John. Hey, Rich.
So today we're going to talk about VPCs and AWS and getting set up for ECS. But before we do that, what have you been up to this week, Chris?
Oh boy, I cannot believe I have now reached that point in life where I'm going on college visits with my son. So this week started that process and just again kind of like just scratching my head, wondering how we got here. Like time has flown by, and getting ready to send one off to college.
Nice. And how did the college visit go?
It was great. It was an awesome experience. It was really cool to see his excitement. I think it definitely makes this idea of college much more tangible. I think it's been a pretty abstract concept, but to actually walk around a college campus and see the classrooms and the labs and talk to the faculty, see the facilities, go visit the on-campus housing. It just made it all so real and pretty exciting. And like I said, making that just so much more tangible. So it was very much well worth the time, and it's a great experience.
Super fun. Very cool. How about you, Rich? What have you been up to?
Yesterday, we launched our largest project. It's a science magazine. Does about, I think it does a couple thousand uniques a day, so even for traffic.
Are you talking about the journal, Science, the journal? Like the academic journal?
Oh, no, it's nothing like that size. It's called Cell Culture Dish. It's a...
Oh, okay. Cool.
It's just
when you said science magazine, I was like, whoa, that is hardcore. That's awesome.
Yeah. Thanks for taking me down a notch. It was an awesome project. It was cool. Originally in WordPress, and so you'd think that would actually be an easy transition, but because we re-architected everything, it was actually probably harder than had we just taken it from a totally different CMS. But we had the right timeline, we had the right roadmap, and it was actually the smoothest launch that we've ever had, which is interesting. So knock on wood, we still have today and the weekend to make sure we didn't miss anything huge. But they're heading to a conference, and so it was like a hard deadline. So yeah, I was pretty stoked on it and looking forward to getting some larger projects like that in the future. We did pretty good.
Great, that sounds good. And then as for me, we've been in hiring mode, and we had somebody start this week. So I've been working with that person, ramping them up and getting them accustomed to the idea of working with Docker and AWS. So let's talk about that stuff. It looks like our title today is How to Set Up Your AWS VPC for Running Your Containers on ECS. So we've talked a lot about ECS over the course of this podcast. We've touched on VPCs a couple of times, and I think a lot of listeners that have experience with AWS will know what they are, but it never hurts to start with a definition. What's the VPC, Chris?
Yeah, so VPC stands for Virtual Private Cloud. And so it's kind of the basic unit of isolation from a networking perspective of building out your cloud-based infrastructure in AWS. So you can think of it as just an isolated collection of networks on which to to instantiate and run your resources.
Makes sense. So it's computers and networks between those computers that only you can see, and your competitor cannot get in there and see that stuff.
Correct.
And you have in our list of notes that we're going through today, the next thing we're going to talk about is their primary components. So what kinds of things make up a VPC?
Right. So when you first create it, so by default, when you create an Amazon account, an AWS account, to make it so that it's ready to go right from the get-go, they'll create a default VPC for you. And so you already have that set up for you if you want to use it.
That's just conceptually interesting. I just want to interject because that means that when you're working with AWS, you're always working in a VPC. You're never just sort of there's no such thing as the public cloud where you're intermingling with all the other AWS customers. You're always in your own private cloud, kind of like me every day walking around.
Indeed. Yeah. So you'll have that default VPC set up for you. I think, a lot of people end up using that. For various reasons, you may very well decide to create separate VPCs from the ground up, and then later you can go back and remove that default VPC, if you will. But when you create the VPC, you're going to decide like what is the basic address space that you want to use and how big you want that to be. And so kind of just some design decisions there for you to just understand like what is this particular VPC going to be used for? How big of an address range do you need to use? And that will kind of be informed by how you want to slice it up. So you can slice it up into sub networks. Short is subnet is what you'll typically hear. So you'll slice up your VPC into these subnets. And one of the important characteristics of a subnet is a subnet can only exist in a single availability zone. So a subnet cannot span availability zones. And so at the very least, for availability reasons, you definitely want to have more than one subnet defined inside your VPC, just in case that one of those eight availability zones has a failure if it goes down.
So I think by defining something with a new thing that we don't know about, we may have lost me. We may have lost a couple of other people. So can you just talk a little bit what an availability zone is, so that I can make sense of why I need multiple subnets? So
you can think of an availability zone as essentially like a data center. And at the end of the day, like, we talk about the cloud and it's like, oh, it's just, you can instantly provision things and spin things up and whatnot. But at the end of the day, I mean, these are very real computers they're sitting in racks, and they have very real cables coming out of them and very real power requirements and cooling requirements. And so there's very much physical manifestations of this stuff, and it has to sit somewhere. And so you group these things together into these building blocks, and availability zone are basically one way of describing those building blocks. So you can think of it again as an availability zone is a data center.
I kind of like thinking of it that way because, just sort of intuitively that makes sense, right? The data center is probably going to be online or offline. Like sort of, if something kind of takes out the internet, it'll take out the whole availability zone at once, the whole data center. So that it kind of feels warm and fuzzy. I mean, I realize that it could be like, who knows what it really is, right? It could be like a huge data center and each floor is its own availability zone. We don't really know how they've set things up, but we do know that there's some physical proximity that the computers have to each other when they're inside an availability zone. And so thinking of it as a building is helpful. Yeah.
One thing we do know is that availability zones are definitely geographically disparate from each other. So they'd never have two availability zones in the same building. And actually in practice, availability zones are not necessarily in the same physical location either, right? So they can define an availability zone, and we say it's a data center, but it's actually could be spread over 3 buildings that are all within a couple miles of each other or something like that.
Close enough to have super fast networking among all the machines in it, but far enough away from other availability zones that if something takes out the availability zone, it won't take out the other one.
Correct. Right. Yeah. And these availability zones, like they do have outages. They're not supposed to, but life happens. It's infrequent. But when it does, like the internet completely lights up, right? Like people panic because that's when a lot of these folks that perhaps didn't really think through all the implications of what does it mean for an availability zone to go down? Like, is my application going to still run? And then they find out when it does go down that no, it doesn't. There were some things here we didn't take care of.
Right. So then the thing you said earlier was that subnets cannot cross availability zone boundaries, right? Mm-hmm. And then you also said you should have more than one subnet in your VPC. But the reason I think you were saying that is because you were trying to suggest you should have multiple availability zones in your VPC. And so you could have two subnets inside the same availability zone, but that's not the point you were trying to get at, right? You were trying to say, let's have at least a couple of subnets and one on each availability zone, or on two or more availability zones. Did I get that right?
Yeah, absolutely. So in that instance, definitely the thought process was like you want to have more than one subnet just because for just availability reasons. Like you want to be built out on more than one AZ, because AZs can go down.
Cool.
So make sure you have that. There's other reasons for having multiple subnets, and we'll get into those reasons as well. But spreading yourself across multiple AZs is definitely one of those fundamental basic reasons for having multiple subnets.
Right on. I get it. So where do we go from here?
Maybe we should check in with Rich. Rich, any questions on that?
I'm just trying to follow along.
Great.
Right. So we have a VPC. We're now dividing up into subnets, and these subnets are, give her slices of that address space. You can kind of decide how big you want these subnets to be. Is it going to be, space for a few machines, or is it going to be, 1,000 machines or 4,000 machines, 4,000 IP addresses or whatnot? And so you can slice it up. You're also going to define what region your VPC is in. So maybe that's something we should talk a little bit about as well. So we've talked about availability zones, and that corresponds roughly to a data center. A region is a collection of two or more availability zones that are, again, kind of geographically similar in the same geographic area. Broadly, they're not next to each other necessarily, but they're close enough, and within hundreds of miles, type thing or less. And so a region would have multiple of these AZs within it. And I think there's multiple regions in each one of these markets. So there's in the US, I believe there's 3 regions now. In Europe, I believe there's 3 regions. There's Australia. There's regions in Asia, and the rest of the world and whatnot. So for you're going to define what region you want your VPC in. Again, most regions will have at least 2 AZs, if not more. And so that's something to consider when you are building out your VPC and how many subnets you have. Definitely spreading yourself across at least 2 AZs is important. But if your region supports more than 2 AZs, then that's something very much to consider. It's almost like, why wouldn't you? So if your region has 3 AZs, why wouldn't go ahead and create subnets in each one of those AZs? And then you can kind of think, if you want to further protect yourself from failures, like what happens if 2 AZs go down? And the odds of that happening are incredibly unlikely. But just, again, something to think about as you build this out.
An assumption I'm hearing that I just want to validate is that while we can cross AZs with our VPC, we cannot cross regions.
Correct.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
So we pick a region. The region is usually just picked by what's convenient or where most of our users are. If they're mostly on the West Coast, we might choose California or Oregon. If they're mostly on the East Coast, we might choose Ohio or Virginia. So then after we've picked our region, where do we go from here?
Right. So after subnet, some of the other components that make up a VPC that you'll need to think about will be things like how do you give access to the outside world to this networking? So up until this point, you can kind of think, I mean, just really kind of abstractly, you can just think of this as you now have a network switch that you can plug a bunch of cables into and hook up computers to it. But that's about it. So you think of it like a LAN or something like that. But now how do these things actually go talk to the outside world? How do they go make requests on like a Google API, or how do they send email or whatnot? So they need to have internet access. And so then you have both sides of that. You have to like think about it on things from the internet being able to connect to those machines. So the inbound access. And then you also have the how do the machines themselves make calls out to the internet? So the outbound access. So both of those types of functions have different pieces that you'll need to deal with to set it up. So for that inbound access, you'll want to set up something called an internet gateway. All right. So an internet gateway basically is a proxy server, and it is the kind of the entry point for other computers out on the open internet to go when they want to talk to those computers inside your private cloud, your VPC. They'll go through this proxy. So it's a special thing. It's called an internet gateway, and that's something that is incredibly easy to set up and to use with AWS. It's again very easy in that it is a managed service provided by AWS, so you don't have to worry about availability. For the most part, don't have to worry about scalability because this is again a managed service that AWS provides. That it's built out with all these considerations.
So that actually makes me want to ask just a really rudimentary question. So here we are making a VPC, and as far as I know, we haven't even put any computers in our cloud, right? We just have sort of defined it's going to be in these availability zones in this region, and here's the IP address space that it's going to take up. And the next thing you're going to say is, and here's how you can talk to it from the outside world. Let me just attach an internet gateway to it. But we haven't actually put any EC2 instances into our VPC there. It's just an empty network, right?
Yeah. I mean, you can kind of think of it as like we're building like this big condominium building, right? And so you start with building the building itself to hold all these individual condominiums, and you build out the individual condominiums. And so each floor you can think of it maybe as a subnet. Then you need things like how do you turn on the lights? So you got to make sure that it's wired with electricity and phone and other utilities and plumbing and whatnot. And that's kind of like what we're talking about here. And then those EC2s, that would be like when the residents actually come and move in.
Okay, got it. Yeah. All right, so an internet gateway. The reason I ask is because an internet gateway, if you have done networking before AWS world, it was a computer, and you had to set it up, and you had to, put together routing tables on the thing, and so in this case, since it's a managed service, it's just like a conceptual internet gateway almost. Like we're just saying, hey, here's how you get in, and we're attaching a quote unquote internet gateway to our VPC.
Right. Yeah. So it's a managed service from AWS. You can set up a single internet gateway for your VPC. And that's all you need to really know about. I think the throughput on that is something like 10 gigabits a second. And so
that'll work.
Yeah. It's one of those things. It's super nice. And that like, there's not a lot that you have to do. It's so common. It's definitely one of those things that the folks at AWS have focused on and optimized and just made it a lot easier than what it has been in the past. You have, another thing that we can talk about is just the routing tables and whatnot. So that is another component of your VPC setup will be to define routing tables for and your subnets you'll define what routing table your subnet each subnet should be using, and that routing table kind of dictates what kind of access traffic patterns are allowed. So if you want your subnet to be able to reach the internet and then also have the internet reach it, then when you create that internet gateway, you can add that to the route to the internet gateway to that routing table. And that basically just says, okay, this subnet, when it makes requests, in addition to being able to make requests to everything that's within this subnet, it can also make requests to the internet gateway itself, right? So it's defining that hop so that you can say, okay, I'm going from my subnet to the internet gateway, and then from there, it can now go to the outside world.
And has AWS created kind of a GUI to make it fairly intuitive how to do that? Or is it sort of the way it's always been where you have to understand like a Unix configuration file type of thing?
Yeah, all this is configurable via the AWS console. Mm-hmm. So again, pretty straightforward, especially since like the standard use case scenario is there's not much to it, right? You're basically just going into a route table and saying, add this one route, and you can say what the destination is, and you'll see the internet gateway will pop up as one of those options, and select that, and just then you're done. And that's all you have to really do. And now internet access works on that routing table. And now that routing table can be associated with more than one subnet. So a subnet can't be associated to more than one routing table, but the converse is allowed.
Oh, interesting. So if you have a couple of subnets to set up and you've set up your routing table, you could, and you really want the same routes to apply to both subnets, you could just say, hey, use this one.
Correct.
Interesting. Well, there's so much of this that really depends on having a fundamental understanding of TCP/IP networking. And, when you hear words like routing table, if you haven't spent some time learning how TCP/IP networking works, then that's pretty, it's like, what is that? What is it for? And we don't have time to really explain TCP/IP networking. But what we do, what we should say is that it's kind of a fundamental thing to really understand as a software developer. And it's worth it. If for some reason in your education you missed that piece, it's worth spending a week, really reading about it and coming to understand it, because it's never going to be, it's always going to be useful. It's always going to be something that you rely on throughout your career.
That's a great point. And it's just so true. So, I look back, over the past 20, 25 years, and there's been like so many times where it's like I had to go, set up a firewall, and it was just out of necessity, right? It was just like, I needed to have secure access between my home office and, someone else's home office. And we wanted to make sure it was secure. So we went and bought a Belkin switch that also had VPN capabilities inside of it, right? So what does that mean to set it up? You go through the manual and you play with it, and you're kind of forced to like understand it at a level of like, okay, what is a network switch doing, and ports, and forwarding rules, like what is a VPN, how does that work, tunneling, like all this kind of stuff. And the amazing thing is that, like you said, it's still applicable. Like mm-hmm. all these concepts, like they have not changed, right? Mm-hmm. Like it's just, this is the fundamental way of how networking works. And that's not changing, until we go to, I don't know, photon packets or something like that, right? I mean, it's right. Like we're quantum computing or something. Like this is the way it works. So I'm super glad and fortunate that I went through all that, those experiences, because it does make things like figuring out like how VPCs work, and understanding things like firewalls and gateways and network address translation, which is another thing we'll talk about later, like how all that stuff works. These are the same things that, they work the exact same way 15, 20 years ago.
Right. I think that's a great place to just kind of wind it up for this week. And then we'll just jump back into talking more about setting up VPCs for your containers on ECS next week.
Awesome. Thanks, guys. Later.
Bye, Rich.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/27. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.